Hey math kids, today we're going to talk about simple discrete data, and we are going to be in chapter 11 section D. We're going to do example number 4, and that's it. So for this example there are 30 children and they attend a library holiday program. Their year levels at school were, so it's going to be a lot of data, I apologize, 7, 6, 1, 2, 3, 9, 7, 7, 11, 8, 10. This is too much. So once again, this will be printed in your book. So if you just want to look in your book, it's going to look a little bit nicer than how I'm doing it. There's 4 8s. 7 6. 4 6 is 1, 2, 3, 4, and 9 6 9. Alright, there's the data, and that's what grade they're in. 30 children. Okay, record this information in a frequency table. Include a column for relative frequency. Okay, so what we're going to do, we're going to say year level, or you could just say grade. And so all the year that are represented, we have 6, 7, 8, 9, 10, and 11. Okay, now we're going to tally all of this up. And so if we count the 6s, 1, 2, 3, 4, 5, 6. Actually, I don't like the idea of the tally. Your book does the tally, but I think we can just count it and jump right to the frequency. I think it's a little redundant. So we're going to do the frequency. And so that was 1, 2, 3, 4, 5, 6. There's 6 6s. And then we count the 7s. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 of those. And then we count the 8s. 1, 2, 3, 4, 5, 6, 7, 8. 8 8s. Then we count the 9s. 1, 2, 3, 4. 4 9s. 2 10s. And there's just this 1 11 right here. Okay, so that's our frequency. As a double check, we want to make sure this adds up to our total, which is 30. So if we plug that into a calculator, we'll see that that's 30. Now, relative frequency. What we do with that is we just figure out what percentage of the total it is. So we're going to do like 6 over 30. Go to our calculator. Six divided by 30. We get 0.2. 9 over 30. 8 over 30. 4 over 30. 2 over 30, and then 1 over 30. And then write all those out. Okay, so we have 9 over 30. So that's 0.3. And if we continue to do that, we'll get 0.267, 0.133, 0.067, and 0.033. So that's our relative frequency. That's basically just asking what is the percentage of the total that this 6 represents. Well, that's 20%, or this 9 represents 30% of the data. And so that's what A was asking us to do. Now, construct a column graph to display the data. So I'm going to zoom out again. Okay, so we're going to do year level right here. So year, So that's going to be 6, 7, 8, 9, 10, 11, 12. Guess I ran out of a little bit of space. And then this one's just going to be frequency. Okay, so frequency. So all we really need to do is graph these columns. And so our frequency, our highest frequency is 9. So really we only need to go up to 9. And I'm just going to drop by 2s. Then 0. So 6, which should be 6 tall. 7 should be 9 tall. Color those in. 8 should be 8 tall. 9 should be 4 tall. 10 is 2 tall. 11 is 1 tall. Okay, so our graph should look a little bit like that. Obviously the book draws it a little bit better than I do. Okay, part C. What is the modal year level of the children? So all that means is we go to the frequency. We can look on the table or on the graph. So on the graph we see that 7 is the tallest. Over here we see that 7 gives us the biggest number, and so the modal year is 7. Okay, part D. Describe the shape of the distribution. Are there any outliers? So what well, this is asking, it's easiest to look here. So if we were to draw like a curve around this, just to kind of exaggerate it, it would be like this. Whoops, that's a little too weird. It goes like that. Since the tip, or like this part that's kind of like leveling out, so that we have the big part and then it levels out towards the positive direction, we call this positively skewed. Okay. If we were to have one that looked more like this, whoops, not that. I'm not doing a good job drawing this, but if it went more toward, if that like this piece went more towards the negative direction, then we'd say it's negatively skewed. But for our data, it's this situation, positively skewed. And there are no outliers on that. So outliers would be things that are like way out there. So if we had like a 27th grade student, or if we had like a kindergartner would be considered an outlier because it'd be way over here. Okay, now E, what percentage of the children were in year 8 or below? So if we're just looking at 8 or below, we can actually just add up all these percentages right here. So we go to our calculator, we say 0.2 plus 0.3 plus 0.267, and so that's about 77% if we round it. But since in IB we want to do 3 significant figures, we're just going to keep all of them, so it's 76.7% that are 8th or lower. Okay, and then what percent of the children were above year 9? So above year 9, we look at year 9. Year 9 is not above year 9, so we're not looking there. We're only looking above. And if we add those two, we're going to get 0.067 plus 0.033, and that is 10%. So 10% below year that's everything for this video. If you need additional help, come to Math Lab. Until then, calculator.